On our quantum journey, we will experience quantum leaps from time to time. After all, we are made of particles, aren't we? We are taking our first leap with this video. We will embark on a journey to the 19th century together. I will tell you an incredible story, the story of one of the most extraordinary minds in history. Picture all the developments of the 20th and 21st centuries, the introduction of machines into our lives, the machines in our homes, laundry, dishes, factories, everything that will shape this century and our future. I'm going to tell you the story of the man who lit the fuse for all of this, the man who changed our perspective on matter, nature, light, magnetism, the story of Michael Faraday. Beyond all his inventions and discoveries, his life story alone is one that we should all still look up to today, a story that will inspire all young people, all of humanity, because he truly started from scratch. Literally, he was a man who started from nothing in every sense. So before getting into the technical details, let's talk about where Faraday came from. Born in London in 1791, Faraday was one of those who started life at a disadvantage. His father worked for a blacksmith, and they really struggled to make ends meet. When Faraday reached school age, he started school, but his grades weren't very good, and he also needed to earn money. On top of that, his teachers treated him quite badly because of his failure and slow learning. For this reason, he was taken out of school before even completing his primary education. This event, which seems very sad, may have led to developments that were very important for Faraday and for us. After leaving school, Faraday began working at various jobs. When he turned 15, he started working as an apprentice at a bookbinding workshop owned by George Rebow, helping to bind books. Would it be an exaggeration to say that a child starting an apprenticeship at a bookshop to earn pocket money in the 1800s would completely change human history? Perhaps one of the most beautiful examples of the butterfly effect. While binding books at this bookshop, Faraday also began to glance at the books. One sentence, one paragraph, and soon he was almost addicted to reading. He would first bind the books that came into his hands, then read them. Every single one. Whatever he could find. He couldn't stop. He read. History, alchemy, literature, poetry, but books on physics and chemistry interested him the most. The more he read, the more curious he became. And two books in particular would be very important to him. Isaac Watts' The Improvement of the Mind. This book discusses how dangerous dogmas and cliches are, the importance of critical thinking, and why a person should question, and it discusses some principles and ways of thinking for all of this. Faraday had read this book countless times and would apply everything he learned to his own life. The other book that changed Faraday's life as he began to think more critically was Jane Marcet's Conversations on Chemistry. This book was actually the notes taken by Jane Marcet, who attended public lectures on chemistry given by a name we will mention shortly. They were just notes describing the processes and results of the experiments, but they would excite Faraday greatly. He was even trying to conduct these experiments at home with the experimental materials he had acquired by setting aside what little money he had. Faraday, who worked in a bookshop for about 7 years and read countless books during this time, would have his life changed by a ticket given to him by a customer. It was a ticket to a conference attended by the London's aristocracy, the conference where the experiments mentioned earlier in the book were conducted, Sir Humphrey Davy's chemistry conferences. At that time, these types of public scientific conferences were what Peter Kay shows are today. They were one of the greatest entertainments for people. Scientists, experimental physicists, and chemists took the stage to talk about their theories and conduct experiments. For many people, these shows were nothing more than an evening's entertainment, but for Faraday, they were extremely important. But there was a problem. Faraday was not a nobleman. He didn't even have proper clothes. In fact, when he attended these conferences, the nobles would find him quite strange. He would feel very excluded. But he would attend anyway. His curiosity would make him ignore class distinctions. He would attend all the conferences, taking notes on every second, every word Sir Humphrey Davy said, down to the last letter. While everyone else watched the experiments and applauded, Faraday's eyes sparkled. And at the end of this series of conferences, Faraday would produce a 300-page book, adding his own comments and insights to the notes he had taken. Look, let me remind you again. This man was ostracized in elementary school for being a slow learner. He was scolded. He hadn't even finished school. And he really had no money. He had to work. He had to survive. Yet this man was attending lectures on chemistry, physics. He was taking notes and developing himself in this field completely on his own, without any help, for no personal gain, without earning a penny, just to satisfy his curiosity. He was doing this while the scourge of class division, which we will discuss shortly, was still haunting him. He would eventually have his notes bound into a book at the bookbinders and send it as a gift to Sir Humphrey Davy, whose lectures he attended. A tragic accident would occur, one that would be sad for Humphrey Davy, but would change Faraday's life. Davy was injured in an explosion during an experiment and temporarily lost his ability to see and write. He needed help. While searching for an assistant, he was approached by the young man who had so successfully turned his lecture notes into a book. He asked him to help him, even if only temporarily. After assisting him for a while, Davy regained his ability to work, and Faraday reluctantly returned to bookbinding. But shortly after Davy's actual assistant was fired, Davy made Faraday a formal job offer. The job was to be his chemistry experiment assistant. Would you like this job? Was that even a question? Working at the Royal Institution, an institution in London dedicated to the research and advancement of science, where incredible research was being done and where all the famous scientists visited, was an offer he couldn't possibly refuse. Our bookbinder boy started working at the Royal Institution, and better yet, he would now be doing what he loved most. He would be working with science. The date was March 1st, 1913, and he was only 21 years old. And just 8 months later, he would accompany Sir Humphrey Davy on an 18-month tour of Europe as his assistant, where he would have the opportunity to meet very important scientists like André-Marie Ampère and Alessandro Volta. But his poor childhood would not leave him alone. Davy's wife was not very happy about taking this non-noble young man with them, and she constantly belittled him and reminded him of his origins. During this time, he seriously considered giving up everything and returning to his modest life, but his conversations with Volta and Ampère had lit a fire in his mind that would never be extinguished. Meanwhile, this period was also when the most talked about topic of the last century, electricity, was reaching its peak. Everyone was working on electricity, and everyone was trying to understand this strange power. But the biggest problem at the time was that no one could overcome the perception that forces of nature were separate and independent. No discovery had yet been made that would connect all these forces and simplify everything. But our bookbinder boy would change everything. The importance of his meeting with Volta, who we mentioned earlier, would become apparent here, because Volta had recently invented the battery and created a revolution. Here we can understand where the unit of measurement we use today, the volt, comes from. Everyone was experimenting with this invention. Davy was one of them. Together with Faraday, they conducted countless experiments in the laboratory and, like everyone else, tried to make sense of this strange force. During this time, one man would discover something very strange. Until then, everyone was certain that electricity was a current flowing through a wire, but Hans Christian Ørsted, a Danish physicist, accidentally noticed that electric wires changed the direction of a compass needle. That was very strange. How could a force flowing through a wire affect something it didn't even touch? Ørsted had found this experimentally but could not explain it, but this discovery would change everything. Faraday, who picked up and read anything he could get his hands on in his spare time, would come across an article Ørsted had written about this experiment, and that's when the pieces started to fall into place. Faraday wasn't alone. Led by important figures such as André-Marie Ampère, Pierre-Simon Laplace, and Dominique-François-Jean Arago, a new era of discovery was unfolding in the early 1900s. Those who correctly interpreted Ørsted's discovery would leave their mark in this era. Building on this discovery, Faraday would develop the thesis that electricity must generate a magnetic field. And through a few more experiments, he would also discover that this magnetic field was circular. He would uncover this by placing several compasses around an electric wire. The questions kept coming. Like a child with a new toy, he tried everything. And finally, he would perform his famous mercury experiment. If electricity created this type of magnetic field, would a magnet follow it? To do this, he placed the magnet in a bowl filled with mercury with the south pole fixed and the north pole on the surface. Then he placed a wire in the bowl and, after applying an electric current, saw that he was right. The magnet began to rotate around the wire. Then he tried the opposite. He left the wire free while the magnet was stationary. And again, the same result. This time, the wire began to rotate around the magnet. Do you know what Faraday had discovered? It was the first electric motor in history, converting electrical energy into mechanical energy. It was the first draft of an incredible invention that would provide energy to all of humanity. And actually, more importantly, it explained electromagnetism, that electricity and magnetism were one and the same. Forces that had been thought to be unrelated until then had come together. Faraday did what a top-class scientist should do, and simplified it. Over the next decade, Faraday carried out many different studies, which I will mention a little later, and during this process, this discovery was rapidly developed with the contributions of other scientists, and electric motors began to become more and more useful as time went by. But Faraday's work with electricity was not finished. This time, in his correspondence with Ampere, Ampere had told him that a coil of wire could also be a magnet. Based on this idea, Faraday would again conduct hundreds of experiments. He would spend months thinking about it, leaving no stone unturned. What he was trying to discover was this: if an electric field creates a magnetic field, could a magnetic field also create electricity? After various failures, he tried to transfer current from one coil to another without contact by placing the two coils in a suitable position. And he observed a movement in the compass he used for measurement. But it was a very weak and momentary movement. The compass moved momentarily when he applied current and when he cut it off, but then it returned to its original state. There could only be one explanation for this. The magnetic field stabilized at a certain point, and therefore the compass did not continue to move. For this, he thought of a very simple but very clever solution. He moved the magnet back and forth inside the coil. And with each movement, he observed the compass moving. This was magnetic induction, or induction in its simplest form. But there was still a problem. This effect was still momentary. He wanted to make it continuous, and he thought of a solution for this. He built a larger mechanism and tried to make this current continuous by using a conductive disc and rotating it. He conducted this experiment in October 1831, and this would be perhaps Faraday's most important achievement. He would succeed in creating a continuous electric current with a machine, and this was the first dynamo in human history. In my opinion, it was one of the most important discoveries in human history. Over the next few years, many scientists, including Edison, would develop this invention. Do you know why it was so important? Because this discovery was the basis for everything that provides us with power, that provides humanity with power in the form we know today. All power plants, dams, generators, transformers, converters. Thanks to this discovery, which can be converted into current at different levels for different purposes, not only the things I mentioned, but also televisions and computers would emerge. The converters used especially in electronic devices are also based on Faraday's discovery called the induction coil. Of course, everything I mentioned was the separate discoveries of other great names, but all of them, every single one, was based on the discoveries of a man playing in his small laboratory. He was a spark that turned into a fire. Is that all? Of course not. Faraday achieved many great things, big and small. For example, with the formulas we call Faraday's laws of electrolysis, he paved the way for the production and processing of very important raw materials, especially in the electrochemistry industry. Furthermore, the logic behind lithium-ion batteries is also based on these laws. So if you can watch this video on your phone, he's the one you should think. Apart from that, he was also one of the first to liquefy gas. This laid the foundation for the refrigerators we use in our homes. He's also the discoverer of benzene, one of the most important substances in chemistry. He invented the Faraday cage, which creates an electromagnetic dead zone that protects against electric shocks. This is a dead zone that even disrupts mobile communications. But perhaps one of the most striking was his relationship with light. Faraday proposed an idea that seemed crazy to everyone at the time, that electricity also emitted invisible light. He even claimed that everything, even the sun, emitted light we couldn't see. He would say that light was a type of electromagnetic wave. Despite all his discoveries and inventions, everyone would laugh at this crazy idea. No one would believe it was possible. He himself would not be able to prove it, for one reason. But on the other hand, our bookbinder boy, who hadn't even finished elementary school, was at the Royal Institution in London, attending for the first time as an audience member, rejected because of his social class, the child no one believed in. Here, he would become a professor. Of course, this would not be easy. At first, he would harbor a kind of resentment towards Sir Humphrey Davy, whose assistant he was, because the tables had turned. He would accuse him of all sorts of things and refuse to publish his research. He would try to put obstacles in his way every time, but he couldn't stop him. He lost his life, and years later, this boy who had listened to him would start giving lectures to people at the Royal Institution in his place. It's an incredible story, really. But we mustn't overlook one thing. Despite all these incredible achievements, we still need to talk about why quality education is important. Now, Faraday was an experimental physicist. There are also theoretical physicists. Faraday didn't deal with formulas or theories. He conducted experiments. He reached conclusions. And as we can see, he was perhaps the best in history in this regard. But sometimes you also need to be able to explain what you say. You need to be able to make certain connections. For example, when you say light is an electromagnetic wave, you need to prove it. At this point, Faraday was unfortunately, how should I put it, inadequate, until another brilliant mind, a young man, took up the baton, believed in Faraday, would fill in his gaps, build upon them, and change the world at least as much as Faraday did, perhaps even more radically than him. And later, it may sound a bit strange, but he would influence and change things as profoundly as Einstein or Newton. An incredible name, James Clerk Maxwell. I think you understand why I decided to mention these names before talking about time travel, quantum gravity, or string theory in quantum physics. Because you will eventually understand that these names, these theories, these discoveries are all connected. They're like bricks placed one on top of the other. They are tools that ultimately lead us to the theory of everything we will discuss. We talked at length about Tesla, but there were things we left out. We will return to them, so our journey continues. Stay tuned, and as always, until we meet again, it's good to have you here. With love.